This video covers systems of linear inequalities. So in this problem, they ask us to graph the solution to the system 4x is greater than or equal to y, and x plus 3y is greater than or equal to 6. So when you're doing this, the first thing you want to do is you want to graph both of the inequalities, and specifically, not even really the inequalities, but you want to graph the lines. So we're going to graph the line 4x is greater than or equal to y. So it has to be in the form y equals mx plus b to easily graph it. So this in essence would say y equals 4x. And again, I'm going to ignore the inequality for now. We're going to deal with that a little bit later on. So this one does say y equals if you flip the y and the 4x. So now I'm able to determine the slope and the y-intercept. In this problem here, the slope is the numbers attached to the x, which is 4 over 1. And then the y-intercept is just the number. And in this case, there's no number, so the y-intercept is 0. So we're going through and we're graphing this line with a y-intercept of 0 and a slope of 4. The slope, the number in the numerator, the 4, means that we go up, and the number in the denominator means we go to the right. So from here, we're going up 4, right 1, and we're plotting another point, and we can do this a few times. And then we go through and we make our line. One thing I will stress is we need to see if the line is solid or dashed. In this problem, we have an equal to sign with our inequality, so we know our line is a solid line. So I'm making a solid line that goes through these points. I'm going to deal with the shading a little bit later on. Right now I'm just going to graph my two lines. So I go to my next inequality. The x plus 3y is greater than or equal to 6. We're trying to go through and graph this, so we need to get the y by itself. The first thing we need to do is we need to move the x over to the other side. And to do that, we would subtract x from both sides of the equal sign. So that gives us 3y equals 6 minus x. And then we still have to get the y by itself, so we'll divide both sides by 3. And when I do that, I will get y equals 2 minus 1/3 x. So remember, there's technically is a 1 in front of that. So now we go through and we identify our slope and our y-intercept. Our slope in this case is the number attached to the x, which is negative 1/3. And then our b or our y-intercept is just the number, which is 2. So again, I'm going to go through and graph this inequality. So I have a y-intercept of 2. And then the numerator says I go down 1, and the denominator says I go to the right 3. So down 1, right 3. I'm going to do this a few times so I have a nice pretty line. You can also go up 1, left 3. And then we connect our points with a line. The best line I can get there. And I should have mentioned here, we know that this is a solid line because of the equal to in the inequality. And again, I'm not going to deal with the shading for right now. I'm just going to graph the two lines, which I have graphed. Hopefully now you see that the graph is broken up into 4 regions. I have a region 1, a region 2. Ooh, that is not good. I have a region 2, I have a region 3, and I have a region 4. And we'll actually put a 1 there typed up. So now I'm going to go through and I want to shade one of these 4 regions. That's how I'm going to know which points correctly make this inequality true, this system of inequalities true. So I'm going to choose a point in any of these 4 regions. I'm just going to start off choosing point 4, -2. So I'm looking at this point right here. 4, -2. If I were to shade region 3 here, I would have to make sure both inequalities are true. So I'm going to plug both of these. So I'm going to plug this point into both inequalities. If both of them are true, then I'll shade that region. Only one of the 4 regions will be shaded. So I start off 4 times x, x is 4. So I have 16 is greater than or equal to y, y is -2. This here is a true statement. Woohoo! Ooh. All right. Does not like me putting just a line there. Let's do it this way. Boom. Except now it's not going to even. Now it's a dot. All right. All right, there we go. So now I need to take this same point and plug it into the second inequality. So to do that, my x is 4. And then I have 3 times the y. My y is -2, so 3 times -2 is -6. And I want to know, is that greater than or equal to 6? So we finish simplifying here. 4 plus -6 is -2. Is -2 greater than or equal to 6? Unfortunately, no, that is not true. That is a false statement. So I know region 3 is not where I'm going to shade. Region 3 is not where I'm shading. So let's choose a different point in a different region. So again, I'm just going to choose a point here. Let's choose 4, 4. And again, I'm going to take that point and I'm going to plug it into both inequalities. 4 times 4 is 16. And y is 4 for this point. And I want to know is 16 greater than or equal to 4? That is a true statement. Woohoo! But I remember you need to make sure it's true in both inequalities. So we plug it into the second equation. So we have x, which is 4, plus 3 times y. Y is 4. 3 times 4 is 12. And I want to know, is that greater than or equal to 6? Well, 14 plus 2, or sorry, 14, oh my. 4 plus 12, that there gives us 16. 16 is greater than 6, so this is a true statement as well. Woohoo! So that means I shade the region where 4, 4 is located. I'm just going to do a quick, nope. I do not know why those lines keep extending up, but any value, any ordered pair in this region, if it be 10, 10, if it be 100, 100, if it be 6, 1.5, makes this inequality true.